Evaluation of laptop charging connectors. Have you ever noticed that older laptops came with bulky chargers and different charging ports, while today's laptop can offer be charged using the same USB Type C charger as a smartphone? Laptop charging technology was evaluated tremendously over the past 3 decades. In the early days, every manufacturer designed its own proprietary charging connectors, making chargers incompatible between brands. As laptops become thinner, faster, and more power hungry, charging connectors also became smarter. Today's ESP Type C connectors can not only charge a laptop but also transfer data, output video, and communicate with the charger to deliver exactly the amount of power the laptop needs. In this video, we will explore the complete evaluation of laptop charging connectors from the early proprietary connectors of the 1990s to modern USB Type C charging and understand why each technology was introduced and how it improved over its predecessor. So, in 1990 to 2000, proprietary laptop charging connectors introduced. After that, standard barrel DC connectors. Then, smart charging connectors. Then, magnetic and slim charging connectors. And then USB Type C charging. In future of laptop charging, here during the early 1990s, laptops were become popular in business and education, but there was no universal charging standard. Every manufacturer designed its own charging connectors based on the laptop's electrical requirements and physical design. Companies like IBM, Toshiba, Acer, Dell, Sony, and HP all used different charger shapes, voltages, and connector size. At that time, laptop chargers were relatively simple. Their primary function was to convert the alternating current from the wall outside into DC current, which could safely power the laptop and charge its battery. Most chargers delivered between 10 volts and 20 volts, depending on the laptop model. The charge connector itself usually contained only two electrical contacts. The center pin carried positive voltage from the adapter while outer metal sleeve acted as ground, the completing electrical circuit. The laptop's internal power management circuitry then distributed this voltage to various components such as the motherboard, processor, display, and battery charging circuit. All through these charges were reliable, they created a major inconvenience. Every manufacturer used a different connector size, so users could not borrow chargers from friends or colleagues. Even laptops from the same manufacturer sometimes used different connectors. If a charger was lost, replacing often required purchasing an expensive original adapter. Using an incorrect charger could result in insufficient power, charging failure, or even parameter damage to the laptop. This lack of compatibility became one of the biggest challenges in the growing laptop market. Here, as laptops become thinner and more affordable during the early 2000s, manufacturers gradually standardized around the barrel DC connector, also known as cylindrical power connector. All through the different brands still use slightly different sizes. The overall design become much more consistent. A typical barrel connector consists of two main electrical contacts. The central pin carries the positive DC voltage, usually around 90 to 20 volts, with a outer cylindrical sleeve provides the ground connection. When the charger is plugged into the laptop, electrical current flows from the positive pin through the laptop's internal power circuitry and returns through the ground connection to complete the circuit. Barrel connectors were simple, durable, and capable of carrying relatively high current, making them ideal for powering laptops. Unlike mobile phone chargers of the time, laptop chargers needed to supply much power, much more power because laptops consumed significantly more energy than smartphones. A typical laptop charger could deliver anywhere between 45 watts and 125 watts depending on the laptop model. Despite becoming more common, barrel connector still lacked communication between the larger and charger and the laptop. The charger continuously supplied a fixed output voltage regardless of the laptop's actual power requirements. If a charger with insufficient wattage and connected, the laptop might charge very slowly or fail to charge while under heavy load. Although the barrel shifter connectors remained popular for many years due to their simplicity and reliability, manufacturers soon realized that smarter charging technology was needed. As laptop processors became faster and batteries became larger, manufacturers introduced smart charging connectors that could communicate with the laptop before delivering power. This was a major advancement compared to the earliest chargers that simply provided a fixed voltage. Companies such as Dell and HP added a third electrical contact such as identification pin and smart pin. In addition to the traditional positive and ground connections, this extra pin transmitted digital information between the charger and the laptop. HP introduced a similar smart pin technology to authenticate charges and ensures that the correct power adapter was being used. This communication significantly improved charging safety by preventing users from accidentally using low power or charges that could overheat or damage the battery. As laptops' design became thinner and more portable, manufacturers began developing smaller and more user friendly charging connectors. One of the most innovative design was Apple's MagSafe connector, introduced in 2006 and widely used throughout the following decade. Unlike traditional barrel connectors, MagSafe attached mag- magnetically to the laptop. If someone accidentally tripped over the charging cable, the connector would safely disconnect instead of pulling the laptop off the table. The simple feature prevented countless laptops from falling and becoming damaged. MagSafe also included additional communication pins that allowed the charger and laptop to exchange information about charging status. An LED on the connector indicated whether the battery was charging or fully charged. Other manufacturers developed slimmer proprietary connectors such as Lenovo Slim Tip connector and Microsoft Surface Connect. These connectors occupied less space inside the laptop while still supporting higher charging currents and smart communication feature. Although these designs improved convenience and safety, there remained proprietary meaning users still needed chargers specifically designed for their laptop's brand. Here, the biggest re-evaluation in laptop charging began around 2015 with the introduction of USB Type-C and USB power delivery. Unlike previous charging connectors that only supplied electrical power, USB Type-C was designed as a universal interface cable of charging devices, transferring data, transmitting video, and connecting external accessories through a single connector. The USB Type C connector contains 24 electrical pins, although in only a few are directly responsible for charging. The most important charging pins are V-bus, which carries power, ground, which completes the electrical circuit, and CC1 and CC2, known as configuration channel pins. The configuration channel pins is what makes USB Type-C intelligent. When a charger is plugged into a laptop, the CC pins establish communication between the charger and the laptop before power is delivered. The laptop requires the voltage and current it requires. For example, 20 volts at 3 amp place, and the charger confirms whether it can safely supply that amount of power. Only after this negotiation is complete does the charger deliver power through the V-bus pins. This process is known as USB power delivery negotiation. It prevents overvoltage, overcurrent, and overheating, making USB Type-C and one of the safety charging technology available. USB-C chargers can support multiple voltages levels, including 9 5 voltage, 9 voltage, 15 voltage, 20 voltage. And with the latest USB PD 3.1 specification up to 48 volts and 240 watts, this means the same USB C charging can power smartphones, cable, ultrabooks, gaming laptops, and even monitors, provided both the charger and device supports the required power level. Another major advantage of USB Type-C is its reversible connector. Unlike earlier connectors, users can insert the cable in either orientation, eliminating the frustration of trying to plug it in the correct way. Today, USB Type-C has become the global standard for laptop charging, replacing most proprietary connectors across the industry. Here, in further future of laptop charging is focused on making the chargers smaller, more efficient, and more universal. One of the biggest innovations is gallium nitride technology. Gallium nitride chargers generate less heat than traditional silicon chargers, allowing manufacturing to build compact adapters capable of delivering over 100 watts of power while being much smaller than older laptop chargers. Researchers are also exploring wireless laptop charging, where power is transferred without the cables using electromagnetic fields. Although this technology is still developing and currently less efficient than wired charging, it has the potential to make laptop charging even more convenient in the future. At the same time, USB Type C continues to evolve the higher power limits, faster charging speeds, and broader compatibility across different devices. The long term vision is simple: one charger for every device, from smartphones and tablets to laptops and monitors. Here, the conclusion is the evaluation of laptop charging reflects the industry's the shift from the simple and simple power delivery to intelligent power management. Early laptops relied on basic proprietary connectors that only carried positive voltage and ground. The smartphone connectors introduced identification pins to improve safety and compatibility. Finally, USB Type C transformed charging into a universal intelligent system capable of negotiation power, transferring data, and supporting multiple functions through a single connector. As technology continues to advance, laptop charging is becoming faster, safer, more efficient, and increasingly universal, bringing us closer to a future where a single charger can power nearly all our electronic devices.